Hey everybody, this is your first video for the school year and we're starting on lesson 1-2, as you can see, measuring and constructing segments. So most of this lesson we got through in class. We also got through some of 1-3 and I will be doing some of each in this video. So let's look through. We reviewed how to find the length of a segment in class by talking about the absolute value distance between two numbers on a ruler or two numbers on a number line. So you have that you can come back to if you need it. We also reviewed congruence, how two geometric figures like this line are congruent and shown congruent if they have each a matching tick mark. And we talked about the fact that we would write them as geometric figures in other words, we would need to write line segment PQ is congruent to line segment RS. Because these are not numbers that are equal, these are geometric figures that are congruent or same size, same shape. This is how we would write two numbers that are equal, or two amounts or portions that are equal, PQ and RS. All right, let's move to the next page. We are now on page 14, and we talked about how to construct a congruent segment. So we did that construction on the board, and you have it here in your book to review, and that is at the top of page 14. And now we need to move to the bottom of page 14. We need to look at the segment addition postulate. So we skipped some stuff in the middle, which we didn't really actually skip. It was just practice. This example 2 was practice for doing those constructions. And I'm about to sneeze. I apologize. Excuse me. I'm so sorry. I'm sitting here in this cold classroom. All right. So we're at the bottom of page 14, postulate 1-2-2, segment addition postulate. This is actually super simple. This is saying, and I'll just let you look at the line while I read. It says if B is in between A and C, then AB plus BC equals AC, or the distance between A and B, line segment AB, plus line segment BC totals line segment, sorry, my hand's in the way the whole time, AC. So line segment AB plus line segment BC totals or equals line segment AC, the whole length of the line. So part plus part equals whole. Now I'm sure that makes sense to you. That would be like if we said 1 plus 3 equals 4, if those are our distances. The 1 here and the 3 here would equal the whole line length of 4. Okay, now we could also use this in reverse to do some problem solving. We could say the whole line, AC, minus part of it, BC, would give us AB. So the whole line minus this section would, of course, leave us with the length of that section. Or likewise, we could say the whole length minus the small part, AB, would give us line segment BC. So let's move on to do some problem solving with that. We're going to look at example 2 at the top of the next page, which is page 15, using the segment addition postulate or rule. So it writes out for us these pieces of information that we need to know. That's the bold black print. And then it goes on to solve the problem for us. That's how the example problems work. They're always going to be solved for you. So let's look at their drawing. I'm going to read to you what they told us. Oh, actually, this is my drawing. I remember now that I drew that in there. All right, so they gave us information. I had to do the drawing to be able to do the math. Remember, our rule here is draw, 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 label, label, label. So it tells us B is between A and C. So I drew a line. I had no idea where on the line B should go, but I just picked a spot, and it didn't really matter that it was accurate. What mattered is that I had a diagram where I could put in accurate numbers. So I made B somewhere between A and C, and then it went on to tell me that AC equals 14. So you'll see that across the bottom, I labeled that the whole length is 14. It tells us that BC, right here, is 11.4. So BC, the length from B to C, is 11.4. And then it says find AB. We want to find out what the length of AB is. So of course our segment addition postulate says, I'm going to move my notebook over here and see if I can make it so you can see that. Our segment addition postulate says AB plus BC should equal AC, the whole thing. So let's look back. AB, we don't know what AB is, so we'll just call it AB, plus BC is 11.4, so plus 11.4 equals AC, which we were told was 14. Algebraically, we want to get our variable that we're solving for alone, which is AB. So of course we're going to subtract. We're going to do the opposite of the math that's done to get rid of what we need to get rid of. So if this is added, or if it's positive, we're going to subtract or put in a negative. So I'm going to use my pencil for this. Since this says plus 11.4, we'll say minus 11.4. This is just a quick algebra review. And whatever we do to one side of an equation, we must do to the other side of an equation. So 11 plus 4 minus 11, I don't know what I just said there, plus 11.4 minus 11.4 is going to give you 0. And all you're going to be left with on this side is AB. Now 14 minus 11.4 is going to give us 2.6. And that's our final answer because they wanted to know what the length from A to B was. Now you didn't actually have to write this algebraic equation out the way that I did. I think you could have done this problem probably without it. You could have just looked at it and said, okay, I know that this segment plus this segment equals the whole thing, according to the segment addition postulate. So what is the big number minus the part number? That's going to equal the other partial number. So the whole thing minus part is going to equal the other part. So I would have just said, what's 14 minus 11.4? And I would have gotten 2.6. All right, let's move on to example B right here. S is between R and T. Find RT. So they drew it for us. Remember, if you had to draw it, you would have drawn a line with R and T on the end because you knew that S was between them according to the problem. And in this diagram, they give you the lengths or the numbers to represent it instead of giving you that information over here in the problem. So they give you a problem and a diagram. So they told you that S is between R and T, and they want you to find out the length of RT with what you're given with all the parts. So you're told that RS is 2x plus 7. You're told that ST is 28. That would be line segment ST. And they showed us that the entire line segment from R to T is 4x. Here's how we do that problem. We're going to use our segment addition postulate, and we're going to say RS plus ST equals RT, or RS plus ST equals RT. Now, of course, theoretically, we should have line segments, all of these, but sometimes in the middle of just working the math on a problem, I skip that part just to save time. So for RS, I have 2x plus 7. You can see that that is the length of RS, 2x plus 7. And then that plus ST, which is 28, is going to equal the whole entire line segment, which is 4x. Now I've simply got some math to do. Now they've worked this problem over here for you, but I'm walking through it with you right here. So I'm going to combine any like terms that can be combined to simplify this problem, and I can combine the 28 and 7 because they are just normal plain old numbers, and that's going to be 35. But I still need to keep that 2x over here in the problem and the 4x on the other side of the problem. Now I need to work on getting my x's together. So I'm going to subtract 2x from this side and move it to that side, and I'm going to have 35 equals 2x. So I subtracted 2x from both sides to get all my x's alone on one side of the problem. So minus 2x over here was 0. 2x minus 2x is 0. I'm left with the 35, and 4x minus 2x on this side is just 2x, because whatever I did to one side of the problem, I must also do to the other. So now I have 35 equals 2x. Now these two are actually multiplied together because they're butted up against each other. So since they're multiplied, in order to get rid of the 2 and get the x alone, I must do the opposite of multiplication, which is division. So I'm going to divide by a 2, and whatever I do to one side of the problem, I must do to the other. So I'm going to divide both sides by 2, and I'm going to be left with x over here because 2 divided by 2 is 1, and 1x is the same as just plain old x, and 35 divided by x is 17.5. Okay. Now, the only thing is that that was not actually what the question asks us. They want us to find RT. We didn't find RT, we found what x equaled. We couldn't find the length of RT until we found what x equaled. So now that we know what x equals, we can go back and plug it into the 4x that represents the length of RT, and 4 times x, or 4 times 17.5, is going to be 70. So our final answer for this problem would say line segment RT equals 70. And that would be the final correct answer. All right, let's try one more of those. 3A, actually, let's jump down to 3B. This is your check it out, and these are always opportunities for extra practice. So I'll do it on my notebook. And I'll show you my notebook part in just a minute, but let's read through the problem together. E is between D and F. Find DF. So in this case, we didn't have to draw it. They drew it for us and gave us all of these measurements. So we have E is between D and F. We have the length of DF, we have the length of DE, and the length of EF. And the segment addition postulate tells us that segment DE plus segment EF is going to equal the whole segment DF. So I'm going to write this plus this equals this. Let's see that on my paper. 3x minus 1 plus 13 equals 6x. Now, of course, in order to solve this problem, I need to combine any like terms. The only like terms that I can combine are right here, these numbers on this side of the equation. So I'm going to have my 3x that I'm just going to bring down, and the negative 1 plus 13 is going to be positive 12. And then I have 6x on the other side. Now I need to start getting those x's alone on one side of the problem. So I'm going to move this 3x to the other side of the problem. So I'm going to say minus 3x on both sides, and that's going to create a 0 here. So I'm just going to bring down this 12. I'm done with this because 3x minus 3x equals 0. So 12 equals 6x. Remember, I need to get x alone now. 6 times x is what's holding these numbers together. So to separate them, I've got to do the opposite of the multiplication, which is division. I'm going to divide both sides by 6. And 6 divided by 6 is 1x, or just x, and 12 divided by 6 is 2. So here we know what x equals, but let's go back and find out what the question asked. It said find df. It didn't say what does x equal, it said find df. So df is 6x, so 6 times x, or 6 times 2, is going to be 12, and line segment df equals 12. Okay, we are going to look at another problem, but I'm going to start a new video, so that will be video 2. So when you look at these videos, the first one's going to say lesson, let me look and see, lesson 1-2 video 1. The second one's going to say lesson 1-2 video 2. Make sure you watch all the videos. So I'm going to stop this and start a new video.